We're going to start a new unit focusing on sequences and series, but to begin with, I'd like to focus on sequences. We're going to define a sequence to be a list of numbers in a given order. So first of all, the given order just means that if I have the list 1, 2, 3, that's a different order than 3, 2, 1, even though they contain the same numbers. So a sequence has a very specific ordering, and that ordering makes it unique from a different list with a different ordering. The other thing here you'll see is notation. So the curly brackets tell me that I'm looking at a sequence. The general term of the sequence is a sub k, and then those numbers on the outside tell me the starting value of k and the stopping value here with the infinite. We're going to be interested in sequences that have infinite length. So to make sure this notation is clear, these are 3 examples of sequences, and let's try to write this in the curly bracket notation. In order to find the general term, we need to observe some kind of pattern. So this first one, I have 1/2, 1/4, 1/8, 1/16, and so on. And I can view the general term as 1/2 to the k. If I do so, again, just kind of reflecting on the values, that satisfies k starting at 1 would give me that term 1/2. And the ... implies that this is an infinite sequence. For the second example, terms 2, 4, 8, 16, we can see that that has the pattern of 2 to the k, where k ranges from 1 to infinity. And then finally, the last one, -1, 1, -1, 1, we're going to see this kind of pattern a lot as we move forward. And one way you could represent this is to express this as -1 to the k. And notice that if k is odd, you get -1. If k is even, you get +1. And this pattern would certainly match if we started at k equals 1 and moved toward infinity. So that's what we mean by a sequence. And again, kind of seeing that notation, you want to get into the habit of viewing that as a list of numbers. Once I have a sequence, we're going to be interested in determining whether that sequence converges or diverges. So what do we mean by that? We're going to say that a sequence with general term a sub k converges if the limit of the terms a sub k exists and is finite. Otherwise, we say that it diverges. So the notion of convergence and divergence shows up in a lot of different aspects of this course. But a consistent idea here is we can see this limit existing and being finite to mean convergence. And then beyond that, if that doesn't occur in one way or the other, we'll get divergence. If we go back to the examples we just looked at above, now we can look at them and decide whether or not the given, this was to the k, the given sequence converges or not. So if the goal here is to decide if the sequence converges or diverges, what I want to do is look at the limit of the term as k approaches infinity. So here we have 1/2 to the k. 1/2 is smaller than 1 and positive, and we see that as I raise the power of that higher and higher, it will get smaller and approach 0. So this limit exists. It's a finite number. So this means from our definition that the sequence converges. And we can even go further to say that it converges to 0. If we look at our second example with general term 2 to the k, if I take the limit of this, the base 2 is greater than 1. This is just going to grow without bound and approach infinity. So while the limit exists, it's not finite. So this is one way in which we can say that the sequence diverges. When it diverges, there's no notion of saying what it diverges to. We just say it diverges. Here, I shouldn't have an S. And then finally, our last example, which had general term -1 to the k. If you were to take this limit as k approaches infinity, this is going to oscillate back and forth from -1 to 1. It will never converge to a particular limit. I didn't mean to put an arrow there. What I wanted to say is this is an example where the limit doesn't even exist. And again, that is another way we can see that a sequence diverges.